going to continue with the two triangle groups, LRB1, LRB3. So once you're back into your workbook, highlight, well, I guess what you could do is you could go back to multiple LRBs, highlight LRB1 and LRB3 with your control key, mouse key, and then with the right button of your mouse, select the option so you come up with a context sensitive shortcut menu, create composite TG. Let's call it LRB1, say LRB3. A composite LRB1, LRB3 already exists. If I pull this down a bit, you can see LRB1, LRB3. And let's call it training. And just click on, you can click on show to see what the dimensions are of each triangle group, and click on OK. And if you go back to multiple LRBs, you'll see that the multiple attribute for this new composite is the same as it were for the for each of LRB1, LRB3, which the value was LRBs. Okay, where is that variable? Let's just scroll to the right. Multiple, it's there. Incidentally, you can actually move it. I can move it down here. So it's there. Okay, so the multiple variable, I've just moved it. Okay, so now let's open the composite. So this is the composite, and let's go to, it's got a tab called triangle groups. So let's open the triangle. So it's telling us that the two triangle groups that the composite is linked to is LRB1 and LRB3. And we can actually access these two either one of these two triangles or both of them through the composite or through the database itself. So let's access LRB1 for the composite. And there it is. So everything contained in that individual or basic triangle group is also in the composite. Let's now go to composite datasets. By default, the system's actually set up a composite dataset, and it takes the incremental paid loss. If there are more than one, it would have used the others also. It takes the incremental paid loss array from each triangle group. That's the paid loss array. It tells you if there are any exposures, inflation vectors, are there any premiums, are there any associated triangles, or there's an incurred there, there's a case estimate there. If you suppose you wanted to create a new composite data set, so you click with the right button on the left window pane, and you come up again with the shortcut context sensitive menu, click on new, and you could call it composite DS1 or anything you like. Let's just call it DS1. Now if you click on DS1, it's empty. So you might decide to take the case reserve estimates. This is on the right window pane. Let's change its size. Let's maximize this, and we can shift it up a bit if we want it. Let's take, say, the case reserve estimates for LRB1 with your control key, the paid losses. Move that up. So you've got to be careful where you grab it, and there's a new composite. Okay. Incidentally, you can also create composite data sets within a basic triangle group. You can also do that. So let's now delete this composite that we just created, DS1, and just right button with your mouse, delete it. If I go back to triangle groups tab, and I select LRB1, you might remember there's a tab called composite datasets. So you can actually use the MPTF module with a basic triangle group, and you can create here an incremental composite data set, a new one, and then select each one of these, or one of them, two of them, I guess, put them in there, and create your own composite. And then you can do modeling in PTF, which also includes composite models within a basic TG. let's now, if we want to close this basic TG, we can go to the X with the downward arrow and say close all basic triangle groups. So we're back into the composite triangle group. Now let's go to the Models tab. Now in the Models tab, you can see these little buttons there. You've got Models. Well, there aren't any composite. It says Models there, but it also has Composite. So the two buttons are active. Models is active, Composite, there aren't any. But now if you want to look at related models are the corresponding PTF models. The starting point in PTF is the SGI model, and then you use the wizard, design a model, a forecasting scenario. The starting point in MPTF is already the model that you've designed in PTF. So if you go to related, you'll see a good 1 corresponding to LRB1 and a good 3 corresponding to LRB3. If you highlight these two, let's do that. You click with the right button of your mouse or click on MPTF, it doesn't matter. Let's click with the right button of our mouse, open. And now tile vertically, say minimize regression tables. Maybe let's just close the model display. A lot of the buttons here will be familiar to you, some are new. There's a button called CO, stands for correlation. Can you see it there? It's on the right of the model display button. So click on CO, correlations and covariances, and tile vertically now. And this correlation of 0.305 is the correlation between, if you look at the residual graph, it also has tabs. It has LRB1, that's the residual for that particular line of business, and you have residuals for LRB3, so you can change the tabs. So let's look at residuals versus calendar year. It's the correlation, the linear correlation between these residuals and LRB3, those residuals. In fact, if you put those residuals, take a hard copy of them, which you can from the system. You can go to diagnostic displays. Remember the diagnostic display, the sort of magnifying glass with the 3 diamonds. You'll see there's a tab called Residual List. So you have a hard copy of the weighted standardized residuals, both for LRB1, click on the tab, LRB1, and also LRB3. If you close the diagnostics, I'm going to say that that correlation of 0.305, if you calculated that in a spreadsheet by sort of writing down the residuals by accident year and development year as one column, that's exactly the estimate you'll get in a spreadsheet. And I think, as I've mentioned in a previous video, it now means that if in one line of business the actual outcome is above the trend line in a particular cell, the probability that it is above the trend line in the same cell in the other line of business is now more than 50% because of this linear correlation. Why is the correlation linear? If you go back to your diagnostic tools, I'll wait for you, click on that, and check for normality. Diagnostics, the one I'm looking at the moment is LRB3. I can click on LRB1. And you can see both sets of residuals are normally distributed, so we're measuring linear correlation. Okay, linearity, normality are the same concepts. This is just on the log scale. On the dollar scale, it's exponential. Let's close that. Okay, let's close the correlations and just look at the model display. So that's the one with the, you're familiar with that. And tile vertically. And you notice that as you change the tabs in one display, it also changes in the other. So that's the model display now we're looking at for LRB1 and the residual graph. If you click on LRB3, it also changes tabs in the other display. Now let's look at LRB1, and you notice that the calendar year trend from 98 to 2000 is not significant. When we've estimated this model, what we've actually done is we've used the correlations and the residuals to estimate the parameters. And because these because these residuals are correlated, when you estimate the parameters for one triangle, you're using the other triangle's data and vice versa. In fact, if the correlation was close to 1, you're putting equal weight on each. Okay? So you are in fact doing that. Now, when we estimated the parameters for each line of business now, in MPTF, the parameter estimates are a little bit different to what they would be if you set the correlations to be 0. And that's the kind of estimate you'll get in PTF. Now, you might remember that in PTF, when you looked at the line of business 1, and you just looked at it independently, this trend, in fact, wasn't significant. So let's go and set the correlation to 0. There's an OC button, which is new. It's particular to MPTF, but not PTF. It's called Optimization of Residual Correlations. O with a sub C here, okay? This O here. Now, with the downward arrow, instead of opening the whole dialog box, you can just set all correlations to 0. So now you can see that that trend change is in fact significant. But when we use the information in the other triangle, which will be LRB3, let's click on LRB3 now. The evidence that 98 to 2000 is a change in trend from 97 to, or from 94 to 90, because it's so flimsy. If you use that data also, it tells us that that trend is not significant. So go back to the OC with the downward arrow and then use estimated correlations. Let's do that. Okay. Now we want to remove that parameter inside MPTF. Now it's only a parameter that you want to remove for LRB1. Now OI and double OI is optimization, one parameter, as many parameters going backwards as you have in PTF, but that only applies to the active data set. The O and the double O here also applies to parameter constraints across data sets, not just within a data set. So now I'd like to get rid of this additional parameter, and it's only for this particular data set, and I want to get rid of one, so I'll click on OI, and it got rid of it. Okay? All right. I don't want to also optimize the cross data set. So now we find that the estimate of this trend is 11.993. Incidentally, let's go and look at the correlation again. CO. I'll wait for you so you can find the button. It's in between the model display button and the diagnostic tools button, CO. And the correlation actually has increased a bit to 0.35. Now, if I was to forecast using this model, let's save it, say, as let's call it optimal 1. Okay. Now, apart from having the process correlation, let's go back to CO again, which was 0.35, good practice for just memorizing the buttons. We're also saying that if I were to forecast, I'm going to expand the model display. If I'm going to forecast forward, I'm going to assume that the trend for LRB1 is a random number from a normal distribution with mean 11.93 and standard deviation 3. For LRB3, I'm going to assume that the true trend in the future comes from a normal distribution with mean 8.14 and standard deviation 2.1. But these parameters are also correlated going forward. So on the CO button, there's a downward arrow, so there'll be more menu options, and select parameter covariances and correlations. Well, that's all the correlations, lots of parameters. Select the IOTAs, and you'll find that the correlation is 0.1377. So now what does this mean? It means that if from one line of business, the true trend in the future is above the mean, it plays out to be above the mean, okay, the actual trend that you generate from that normal distribution. Well, let's go and look at the model display again. I think we can close this. Go to the model display. And So if the trend for this line of business is actually above the mean, then the probability for LRB1 that the actual trend will be above the mean is now more than 50% because of the correlation. Okay. As it actually turns out, these are in fact the same line of business, even though I call them LRB1 and LRB3. They're the same line of business, and it's usually you'll find later on that it's unlikely that for two lines of business trends change in the same periods. This is really the same line in different territories. That's my understanding, or where I got the data from. Now, if you look at the trend for LRB1, it's 11 plus minus 3. If you look at it LRB3, it's 8 plus minus 2. Now, are they statistically the same? Well, we can test that. If you click on the double O, what it does it's also going to check to see the double O button, which applies also to between triangles, first has to see whether you can remove any parameters within a data set, within a triangle, and then it also look for parameters across triangles. Are any of them the same? So let's double click, and you can see that this red band says that the trend for LRB3 has been set to be the same as the trend for LRB1. Let's look at the whole model display. It actually tells us that the development year trend is also set to be the same, LRB1 versus this trend here for LRB3. Let's say this model is optimal too. If these in fact were two different lines of business, I would actually use optimal 1 and not have any cross data set parameter constraints, because it's very unlikely that you see that. It's very rare to see that. Now, to remove that particular constraint, you can just click on the red and you come up with a table. It says cross data set constraints. These two parameters have been set the same between 2000 and 2003. Remove all cross data set iotas, the bottom button here, or if you double click on separate, it does the same thing. Let's do that. And now estimate and close, and you can see that that constraint is gone. But if you look at the constraint versus development years, that's still there. To remove that, again, click on the red, and you can just remove all cross data set gammas. Estimate and close. Okay? You can also set constraints manually. You can go to this gray band here and then set up a constraint, add to selection. So the line that's been selected is this one. And you want to make the parameter 2000 to 2003 and LRB3 be the same as LRB1. So you add to selection and you estimate. Well, let's estimate and close. So you can also set up constraints manually. Okay, let's go back and load. So you can go to load. Now when you go to load load model, let's just teach you. You can actually load related models. For instance, you could go to related models and highlight good 1 and good 3. Load. So these essentially were our starting models. Or when you go to load, let's go back to load, you can load a composite. Since we've designed a composite that we've called optimal 1, let's run that. Okay, well in the next video, we are going to follow this up with doing some forecasting, looking at forecasting tables, capital allocation, and so on. Thank you.